More practice with finding least common multiples, because as we move forward, we're gonna have to create common denominators with these fractions. And in order to do that, we need to factor and then find the least common multiple of the denominators so we can create common denominators. So we're gonna take individually both of these. So we've got 4x squared minus 16. And then we also have a 6x squared minus 24x plus 24. So on the left side, I'm noticing that 4x squared and 16 are perfect squares, and it's a difference. So this will factor nicely, but before I notice that, I also noticed that 4 and 16 have a common factor. So of 4. So I'm going to actually factor 4 out first before I try to break this down. And I get x squared minus 4. Sometimes it's a little bit easier to see that it's a difference of 2 squares now. Okay, so then we have 4, and then it becomes x plus 2, x minus 2. So these are the factors, these are the factors of the first expression, and then on my next expression, I'm noticing right now that 6, negative 24, and 24 are all factors, or all multiples of 6, so I'm going to factor a 6 out first. Makes life a lot easier when you're trying to factor. That's going to leave me with x squared minus 4x plus 4. And now I'm looking for the factors of the black group, x squared minus 4x plus 4. Okay, so basically, 2 factors of positive 4 that add to negative 4, right? 2 factors of 4 that add to negative 4. Well, that doesn't exist. There aren't factors of 4 that add to negative 4. So in this case, this black group will not factor any further. So 6 times quantity x squared minus 4x plus 4 is as far as I can take it. And now we're going to look for the least common multiple, okay? This is a kind of a, I don't want to say extreme, but it's a unique situation. So I want to look at every factor, right? So my factor of 4 right here, that's really 2 times 2, okay? I have a factor of x plus 2 to the first and x minus 2 to the first, right? So I'm going to list those again. And then over here, 6, well, 6 has the factors of 2 times 3, right? And then the next red quadratic group, right, this doesn't factor at all, so it's just x squared minus 4x plus 4. So when we're finding the least common multiple, we need to look for every factor that was used, right? And I'm just noticing here I wrote a 1 when it should have been a 2, okay? I need to use every factor that was used, and not only that, but the largest power, right? So I'm going to start with my numbers, the integers, right? So I have a 2 and a 2, or a 2 squared right here, and then over here I have a 2 and a 3. So I'd have to use the 2 squared from this, all right? Because the 2 squared kind of trumps the 2 here, right? So 2 squared is definitely a part of my common multiple, least common multiple. And then I do have this 3, okay? 3 is, it's the only factor of 3 out there, so I have to use it in my least common multiple, right? Next up, there's only one factor of x plus 2 to the first power. No other factors of that anywhere, so I have to use that as a factor, x plus 2. There's only one factor of x minus 2, and it's to the first power, so I have to use that as a factor. And then I have my last big trinomial here, x squared minus 4x plus 4. That is my last factor. So you can clean this part up right here. That's really 4 times 3. So your least common multiple is 12 times x plus 2 times x minus 2 times x squared minus 4x plus 4. This is your set of least common multiple. It's an extreme case, but we just wanted to make sure we touched on all the different pieces there for us, okay?